The GnX endoscope combines several recent advances in optical system design, introducing a more powerful yet less expensive device. The overall goal was to design an endoscope with at least 40 power magnification that transmits sharp images beyond an object angle of 100 degrees. This is the first endoscope designed to allow refocusing of the objective lens. This is important for changing focus during temperature shifts, when liquids contact the front surface of the lens. The front objective lens surface is flat, so no optical power change is expected. But bubbles may sometimes interfere, and some correction will be possible with this endoscope. A 4mm tube design has shown that objective lenses, image conduit, and illumination fibers can be combined to perform at high levels. The ring illumination at the distal end provides an even light pattern over the subject. An exact image of the subject field is then formed on the face of an imaging fiber optical conduit, and this image is transmitted through 50,000 plus internal fibers of the conduit to the proximal end of the endoscope. First stage magnification of the image trapped in the conduit is then accomplished by the relay magnifier. This section of the endoscope uses precision plastic lenses to enlarge the image without degradation and passes the magnified image to the eyepiece or camera coupling lens that's located at the scope's proximal end. Depending on operator option, an image may be either directly viewed or captured in a CCD camera. The eyepiece is quickly removed to allow placement of the camera and camera coupling lens. 7 power magnification in this stage provides an overall image magnification beyond 40 power for the overall endoscope. The eyepiece is by design very insensitive to misplacement, so it is readily maintained in focus. It will be possible later to add dioptric correction for surgeons who need visual correction. To meet both 510K FDA approval for an equivalent device and ease in decontaminating, a flat glass front lens element is permanently sealed inside the 4mm stainless steel tube. Potential contact with a patient is made using only these two materials. The scope's components can withstand 5 megarads radiation exposure, but the preferred method of decontamination is by gas treatment and not by superheated steam or autoclaving. For future designs, the endoscope can be easily modified to different lengths simply by changing the imaging fiber conduit length. It will be possible to create a version that allows interchangeable quick change tubing of varying length without changing the optical performance. Also in the future, the endoscope is adaptable for use of flexible imaging fibers instead of fixed or rigid imaging conduit. These fibers are actually less expensive and will transmit the same image quality.